Okay, moving on from that last video where we looked at setting up our simultaneous equation, we're now going to look at solving, but we're going to have a little talk about how we identify which method is going to be best. Now, we've spent a bit of time on some graphical ways to do it. You could go about it that way. I'm going to stay away from the graphs here and just refer to substitution or elimination. Now, in substitution, it was important that we had a single variable with no coefficient in order to substitute one into the other. Now, just by looking at all our variables here, there's no obvious way that we can make that happen. So I'm going to go and turn to elimination. With elimination, we want to make it so that we can add or subtract one equation from the other and eliminate one of the variables. Now, if we look at the A's, 2A take 3, no, it doesn't cancel out. If we look at our 3B take 2B, it leaves us with a B. That's not eliminated. So we've got to go back to our method where we looked at the lowest common multiple. Okay, I'm going to go and focus on my apples, my A terms, and I'm going to find the lowest common multiple for that. Now, lowest common multiple of 2 and 3, that's quite an easy one. It's 6, okay? So I need to adjust this one here and this one here so that it represents 6 apples in each equation. What that's going to do is going to have a roll-on effect for the rest of the terms in the equation. I can identify that I've got to multiply that by 3 and multiply that one by 2. And because I've done that, I need to multiply everything in equation 1 by 3 and everything in equation 2 by 2. All right, so now my new equations are going to look like this. I've got 6a, 3b, I've got to multiply that by 3, so 9b. And I've got to go and do 3 lots of $13.16, which gets me $39.48. And that becomes my new equation 1. And this one here now means nothing to me. Equation 2, I've got to multiply everything by 2. Okay, so I'm going to have 6a plus 2b times 2 gives me 4b. And then I've got to go 13.74, and I've got to times that by 2 also, which gets me $27.48. Okay, so that now becomes my equation number 2. What I've got now, I've got my A terms, which are essentially the same, and I can now add or subtract equation 1 from equation 2. Looking across to the B terms, I know that if I go 9b subtract 4b, it's going to leave me with a nice positive figure. So I'm going to go about and attack it that way. So my note to myself is that I'm going to go equation 1 subtract equation 2. Now if I go 6a take 6a, I'm left with nothing. That eliminates. That's the whole point that we want to get to here. 9b take 4b leaves me with 5b. And 39.48, I've got to subtract away 27.48 from that, and it leaves me with 12. Okay, I can now get down here, b equals 12 over 5, and that's a nice, neat figure that I can leave here. All right, again, that gives me the first part of my solution. Now, what I need to do is I need to go and substitute that back into equation 1 or equation 2 and find a value for a now. Okay, so I'm going to go into equation 2 because I can see it at the top of the screen there. So I'm going to go and write a little note to myself, sub b equals $2.40 into equation 2. All right, now equation 2 says 3 lots of A plus 2 lots of B. Now instead of saying 2 lots of B, I've just found out that B is $2.40, and that should give me $13.74. Okay, now I probably should have pointed out, it doesn't matter whether you sub back into equation 1 and 2 from up here, which we originally made, or the new equation 1 and 2. It's not going to make any difference, okay? You can put it into anything you like. So let's go through and simplify this now. We're still going to have 3a plus 2 lots of 240 is 480, gets me 13.74. Okay, I'm going to take, what am I going to take? $4.80 from both sides, to be left with 3a equals $8.94. I'm going to divide both sides by 3 now to get $2.98. So, solution for this problem here is b equals $2.40, no matter what order you put it in, and a equals $2.98.